Zero downtime rollouts. Let's move on to that. There are some simple scenarios where zero downtime rollouts automatically happens, right? A very trivial one is if nothing is changing in the schema. So the backdrop is that you have some software, right? You have some. I'm just going to use backend here, but this applies to like any batch processing or something like that as well, right? You have that, and you're trying to release a new version, trying to, in simple words, do a deployment. Then, while you are doing the deployment, some situations are naturally backward compatible. So it's zero downtime. There is no downtime required. Uh, right. The natural and the non-problematic ones are if nothing in data is changing. Let's say you wrote some new function, new API, you modified, you added some null handling into your backend code. Yeah, like you just roll it out. You never think about कि मेरे को downtime लेना है कि नहीं, right? So naturally zero downtime, no problem at all. Generalizing this a bit, right? What is this? Everything that is. Can someone tell कि a change that includes a database change is also naturally zero downtime. You don't need to do anything clever.
Maybe addition of a field is generally a backward compatible change.
Right. So addition of a field, addition of a table,
Yeah.
addition of an index, right? These are backward compatible. So what is the common pattern? Is someone able to spot the common pattern? Actually said the answer. Anything that's backward compatible. Anything that is backward compatible, you don't need to worry about ZDR. Right? So the ZDR, zero downtime rollout, becomes a problem for changes which are not backward compatible. That's where you need all of this cleverness. Um, with non-backward compatible changes. A simple thing is, yeah, it's not backward compatible. You take a downtime, you basically pause the system, and this is important. So what is a non-clever way or a very dumb way of doing this? If you're okay, and it's not so dumb, by the way, it is practical in most real world situations, actually. Believe it or not, most real world situations is you take a downtime, right? Don't stress about it. You don't need to do the whole shebang. You take the damn downtime, and it's worth understanding like, what's that process and why it might not be okay in some situations. So you essentially have your old stack running. You bring the old stack down. So now nothing is running. Then you apply the change. This is non-backward compatible change. So from here onwards, whenever I say change, please consider it synonymous with non-backward compatible change, right? So this is a non-trivial change, right? So you deploy that and then you bring it back up. Except that this is a new stack. And the period of downtime is, right? You might have done this tens of times, if not hundreds of times. in your career, right? Anybody who hasn't done this at least once, right? Now, how do you do a change without taking a downtime? Um, uh, so there is a process for that, right? There is a process for that. Um, I'll come to that. Um, let's cover one more thing, which is, and that's going to be important in understanding this template as well. Uh, which is, if it's a backward compatible change, is going back a step. What are the two ways you can do the deployments, right? So two simple strategies of deployments is something called blue green deployment and a rolling deployment. Anybody can describe what these two are. These are also very trivial concepts. You might already know about it, but let's revise them so that I can use that in the next section.
Uh,
Anybody for describing? Yeah,
yeah, so in blue-green deployment, you have the old stack, and the old stack represent the blue stack, and the green stack represent the new stack. So you will up
yeah,
your green stack, and once your green stack is completely up, you will completely shift the traffic from blue to green at once. So that
right,
is,
exactly.
yeah.
Yeah, so your worldview changes from, um, if I draw smaller squares here, if this is your old stack and here is where the traffic is coming, the second step is to have the traffic coming to old but have the new stack up, and then suddenly have the traffic going to the new stack, and then you bring the old stack down. So these are the four steps through which you do the deployment. And this is called a blue-green deployment. Here, the key problem being that you need to switch at once. All the traffic, 100% of the traffic, not 99.9%, like 100% of the traffic needs to switch at once. And that at once is quite hard um, once you move beyond the basic scenarios. So switch at once is the trick here. What is rolling deployment?
So in rolling deployment, your so at the same time, your old deployment and the new deployment are serving traffic. But as time progress, you delete the machines or the instances for your old pod, and all the pods or the machines for the new deployment will take over.
Yeah.
But it's gradual.
So right. So if you have something like this, and like a lot of traffic is coming, then the next step, you basically bring up two more, and these are new. So the four old is there. There are two new, and um, you bring them up, and some traffic, basically the same amount of traffic is coming, but some of it is going to old, and some of it is going to new, and slowly you kill a few new pods. So now there are going to be only two old pods and four new pods. And again, the same amount of traffic is coming, but uh, a lot of it is, some of it is still going to old and some of it is going to new. And then eventually you take the old pods out. So you slowly replace things. And this is also a very, very common strategy. Here, what is the point to note? How is the traffic going?
The traffic is
Both
going
old,
at a time.
to both old and new.
Mm.
And none of these two you can actually use to do a backward incompatible change. Because this switching at once is super hard, as I mentioned. Does it make sense when I say this switching at once is super hard? Are people able to appreciate that, or should I double click on that?
Apart from the users, is there any other disadvantage like sudden spike on users, or I mean CPU and all, like for Kubernetes?
No, like there won't be a sudden spike. Like you are getting the traffic on the old stack, now you're getting it on the new stack. So whatever traffic was there on the old, the same will come on the new. So there is no spike here.
I mean, let's say 20 ports of old node. So in
Huh.
the rolling out, if we deploy new two port, then we kill the two port again, spin up the two port and something like that.
वो rolling हो गया.
In blue green, we have to deploy 20 more ports. So that spike of this.
So assume that you have infinite infra.
Oh,
Assume that you have all the resources to actually do this blue green, and you can afford to have both old and new deployed for whatever time, few minutes to a few hours, depending on how complex is your deployment. Let's say you have that. Why is it then the switching at once is hard?
So one problem, I'm not sure whether that's there at the pod level, but could be DNS, because DNS is cached at a lot of places. Maybe some
DNS
of
is the same, so you're just switching the pods internally. So the outside world wouldn't even come to know that DNS has changed. Um, right? DNS will just point to your system boundary. So it's going to point to your load balancer
Mhm.
or point to your service ingress. Right? You're nothing doing nothing with load balancer or ingress. So nothing with DNS. But the moment you have multi-region, if you are deployed in Mumbai and in Singapore, how in the world are you going to switch at once? Right?
Yeah.
So that's harder. You might say, nahi bhavin kar sakte hain, why not? We will have the new stack in Mumbai and Singapore, and then we will send the switch command at the same time, right? Sure, you can do that, but there is still going to be a few seconds ka diff between when Mumbai gets and applies that command versus when Singapore gets and applies that command. It's not going to be at the same second. More precisely, it's not going to be at the same millisecond or the same microsecond. Right? There is going to be some difference. So once you are in the high scale territory, that switch is not going to happen at the same time. And this is just 2 regions. Think about like 10 regions. It's an utter nightmare. So multi-region is one problem. Um, um, this is probably the biggest problem. Maybe there are some more, but multi-region is the biggest problem. Yeah. Rolling deployment, though, of course, like both old and new are by definition, they are running at the same time. So if you have a backward incompatible change, your system is doomed because half the folks are going to do something, the other half are going to do something else. They won't understand each other. तो बैकवर्ड इनकम्पेटिबल रोलिंग में तो जा ही नहीं सकता है. ठीक है? Does this make sense? So
Yeah.
then if you come to yeah, Vishali.
Yes, it makes sense.
Okay. So then if you come to ZDR, there is a 4-step process that you can do. Okay. Let's first understand that 4-step template. Anybody knows about this already? Then just raise your hand. Don't say out the solution, but so that I know How many people are unaware? Okay, nobody raised their hands. There is a 4-step process. This is happening from the data perspective, right? So data के साथ आप क्या कर सकते हो? आप write कर सकते हो and read कर सकते हो. If I just consider what's happening with write and read, step 1, write is on the old system, read is also on the old system. This is when you are in the equilibrium, purana jo chal raha hai sahi chal raha hai, there is no issue, and now you want to deploy. So there will have to be 3 deployments. The first one is done, like it is the running one. The next 3 steps, first you write twice. So you write in the old format, right? When I say old, think formats here. You write old and new, but you read from old. And this is a deployment. Each of these steps are deployments. So these deployments will happen through either a blue-green deployment or a rolling deployment. It doesn't matter, frankly, because these are backward compatible changes. Each of these layers are backward compatible to eventually roll out a backward incompatible. So you first write to both, but read from old. Then you continue writing this. Right side पे तो change rollout हो ही गया है. The next rollout, you switch reading from old to new. All the read code is now changed to honor the new data format, and you start serving the new data. And the fourth one is that you stop writing old, you only write new, and you read new. And then the last layer is you clean up the old, right? So you can do the cleanup here in the fourth one itself, or you can do it separately. These are the 4 steps. Very simple thing to appreciate, and this jargon might help, is that each of these layers are backward compatibility layers. Each of them are backward compatibility layers. So you are inserting these layers one after the other to eventually get the net result of a backward incompatibility. This is the technique, this is the framework and the model. We will see a couple of examples. So through that, it will bring more clarity. But does this make sense? Like, any quick questions on this before I take an example? So let's take an example of ZDR with a dB level change. What is a backward incompatible change? The change itself is, anybody has an example?
Modify a data type of a column.
Alteration, deletion.
Alteration of the column.
Yeah, same as what Himanshu said. Vaibhav, what was your answer?
Deletion, I mean the same thing at the end. Deletion of the column or something like that. So if we select star from some, I mean select that
Yeah.
column.
ठीक है, so deletion का भी देखते हैं. So let's take the simpler case first. Change data type of a column.
Then migration will also be sometimes not backward compatible, right? Because new versions might support default value, and we have not get a older version with a default value.
So you're saying adding a default to a column is a backward incompatible change?
Uh, I mean, yes.
Uh, it's
Is it?
not, right, actually.
Uh, Actually, what I'm trying to say is, let's say I'm on version, some Postgres version, and the new version is, if you want to add null value, you have to like write down, uh, it is not accepting null value or default to null. But
Okay, so
older
from a
version doesn't have such a constraints.
y- yeah, so going from a compulsory column to a optional column,
Yeah.
right, which is same as adding a null value or adding a default value in that column. So you're making that column optional. नहीं दिया तो default ले लेंगे. That's actually a backward compatible change, simply because if it was compulsory up until now,
Mhm.
then everybody is complying with it. All your code is adding that value, right? So there is nobody who is trying to actually send it as a blank.
रिवर्स केस शायद बैकवर्ड नहीं
Reverse case, yeah.
Reverse case, yeah. So we will explore that. Making a column not null and removing the default, right? It's same as removing the default. ये कवर करता है. This change data type of column, इसको ले लेते हैं एक बार, right? Any real world example of you guys can think कि कहाँ पे column का data type change करना पड़ जाएगा?
In integer to begin, something like that.
Okay, sure. Any other examples? Smith, maybe?
If
Or
the
Siddharth?
metadata or something increased, initially we think it as a text, sorry, varchar, and then making it a text, because the size is not defined.
Sure. Same as int to begin, but I'll take that. Where character text. This is a big deal. A side note, this is a big deal because the storage engine will handle varchar and text very, very differently. So from the DB engine perspective, this is not a simple change. कैसे करेंगे इसको? Let's go back to the template. I'm wondering if there is a way to keep a copy of this in front of us. I'll just write it again. Write and old, old, old plus new, old plus new, 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 new. If this is your template of a 4-step rollout, how will you go from a int to big int? Let's break that down, right? Let's look at what's going to be in the first PR. So technically first is deployed. So what's going to be in the PR of the step 2? What should that contain? Looking at this, right?
Here, should we assume that the current value and current ongoing value is an integer? I mean, passing the data.
Current everything is integer. Database में भी integer है, code में भी integer है. Everybody works perfectly with integer.
Okay. Then maybe
Right.
the first PR we can create from integer to begin and then insert.
You convert integer to big int. No, that you have shot yourself in the foot, right? Because the moment you convert integer to big int,
Okay,
you
the
have
reading
directly
problem.
applied the change.
Hmm.
Yeah, exactly. So this is a backward incompatible way of doing this change. If you directly change int to big int, you will have to take a downtime of a few minutes. So if you can afford that, data अगर कम है, yeah, you can directly change it. एक PR 10 मिनट का downtime लो, खत्म. And that's not a bad way, right? In most cases, it's actually a simple way. क्योंकि 10 मिनट का downtime might not be a big deal for a lot of systems. तो old plus new मतलब क्या? Old plus new में notice the existence of old. तो old तो तुम नहीं फेंक सकते. You can't discard it. So you have to add something first, because additions are backward compatible. So you just add a column. So now, if everything was writing integer, it will also write a big integer. Right? So you essentially, what's the PR? You add column to the table. So you add column big int. That's one change. In your ORM layer in the application, you need to ensure that whenever people are passing int, the ORM which is handling your object will copy that int to the big int attribute. Is this making sense?
Yes.
Yes.
Yeah.
Yeah. You add a column and you copy the int to big int, and if you merge this, if you deploy this, reading we haven't changed, right? Reading we haven't changed. So everybody whoever is reading, they are just reading int. Int तो था ही पहले से, right? So read side is not affected. आप कुछ extra लिख रहे हो, which nobody is referring now, which is the new big int.
So this here is for inserting new elements, right? Or for copying the existent element to the new row or new column.
This is the first one.
Okay.
You are modifying the logic, so you are not handling historical data. Yeah, that's a flavor. So we will cover that. Basically, if you have tons and tons of data and you want to do a backward incompatible change, then you need to do something extra. So उस पे थोड़ा अलग से आता है. पहले ये base समझ लो.
Okay.
So you just add the big int column. And so now all the new data, the net effect is all new data will have big int. इसके बाद technically I can't skip it. So yeah, thank you Siddharth for raising it, because even in a small enough system you will have like at least a few thousand records. तो कुछ तो पुराना होगा तुम्हारे पास. So once you merge this, the step 2.5 is going to be that you run some query and the column is added now. So after this deployment, the column is added to the DB and the code is writing it to the big int. You copy over the data from int to big int. So you can run some job. तो historical existing data का int को big int में copy करेंगे. And now all the past data is also handled. एक बार तुमने लिख दिया उसको. Right? This, if you if you care, you don't need to run a DB query because that's very dirty. In production, having to run a DB query to do something with the data, it's like big risk. You better go through application layer, because your application layer and your ORM understands the big int column now. This one you can do through the application layer and not at the DB. So you can just write a job, a migration job if you wish, at the application layer. This is important, right? This bit becomes very important in many of the cases. So ये हो गया step 1. All new data will have big int. That is the result now. Third step में क्या करेंगे? तो third step में थर्ड स्टेप में है रीड को चेंज करना. तो व्हाट्स योर थर्ड पीआर? Going a bit fast here. Third PR is going to be change all the reads to big int. And then you merge that. So now everybody has int and big int. So the result is that both int and big int are there, जो पहले भी था. But only big int is being referred now. So int is being written, but nobody is referring to it. And this is a clean deployment. You can do a blue-green on this. You can do a rolling deployment on it. No problem. You can very peacefully do a rolling deployment over an hour to make this happen. So you have committed the step 3 now, and step 4 is you remove the writes. The next PR is write only big int. And if you wish, like delete int column, so you can do that. That'll get rid of the data. We'll go a little bit in detail. This is bad, but yeah, you can do that. But write only big int. तो अभी int का कोई नामो निशान नहीं है. Read तो हट ही गया था. Read you are already doing in big int in step 3. And now you stop writing what nobody is referring. So essentially, in other words, you have deprecated something and then you are removing it. Before deprecating it, the new thing you are adding, which nobody was referring. So each layer is a compatibility layer, backward compatible layer over here. Does this make sense? Before I now start adding all sorts of star marks in this example and look at special cases, edge cases, but ये base case, happy case समझ में आया? Questions बताओ.
Yes.
ठीक है? Okay. No questions. When I say that each layer is compatible layer, backward compatibility layer, what does it mean? It means कि if something goes wrong and you decide कि यार नहीं आगे जा सकते हैं, something is botched and we need to abort, we need to roll back. Then while the deployment was like with downtime, this one, with this downtime, the rollback is also going to be with downtime. So your rollback is also hard.
Hmm.
Once I say it, it seems trivial, but before it was said, it was probably not as trivial, right? So if your deployment is with downtime, your rollback is also with down, which means the converse is also true. If your deployment is zero downtime, like it's like naturally just trivially backward compatible, then your rollback is also backward compatible. क्या दिक्कत है? Right? Can we verify that? with this solution. You are at step 1. So let's try and roll back at every step and see how the rollback is going to happen. So there are 3 possible rollbacks here. Either you roll back from point 2, so you do the rollout for step 2 and then you roll it back, or you do 2 plus 3 and then at 3 you roll it back. So you need to roll back 3 and then you need to roll back 2 also, because they were all part of the same solution. So 2 plus 3 को roll back करेंगे या फिर 2 plus 3 plus 4 को roll back करेंगे. Can we verify if all 3 are possible and if nothing will go wrong? Yeah. Roll back of 2. So 2, you are adding a column and then ORM is copying int into big int. Let's say you have deployed this. The column is now added to the DB. Some traffic came. Those नए rows का data is copied to the big int also. If you roll back, the down migration is going to say remove the big int column. Okay, you can safely remove the big int column. And you are back to int. ORM का जो change था वो भी revert हो गया. So now int is not being copied into big int, but column is also gone. Right or not so right?
Yes.
I think the only thing we have to ensure is the down migration runs at the end. Because when we are rolling back, it's like old and new are running simultaneously.
Yeah, exactly. So the rollback is not as trivial. While you can do this in one shot, or can you? Right? If we are saying this rollback is going to be bad, then हमने क्या बोला था कि deployment अगर compatible है तो rollback भी compatible होना चाहिए. So is my claim wrong here? मैंने बोला कि ये compatible है, मैंने बोला ये zero downtime है, ये zero downtime नहीं है. Even the deployment, even the step 2 is not zero downtime. You need to do this in 2 parts. Right? So let's think about the deployment first. What if you are doing both of these things together? ये इसको थोड़ा सा expand करके समझते हैं. Right? So step 2 के technicalities. Right? If the 2 changes are add a column and copy in ORM into big int, right? इसको समझते हैं blue green में क्या होगा और इसको समझते हैं रोलिंग में क्या होगा. Right? This is one PR. Okay, just keep that in mind. This is one PR, and you are doing a blue green deployment. So the old stack is running. The new stack will come up, right? As soon as the new stack is up, right? When are the migrations going to run in this is the question. Migrations typically run as soon as you deploy something. So as soon as this is deployed, even though you're not sending traffic, it doesn't matter, but ये तो up आ गया, the server doesn't know कि मेरे पास traffic आ रहा है कि नहीं. As soon as the server comes up, it's going to run the deployments. So it's going to run the migrations. So the migrations will run here. And then the traffic switch actually happens. So accidentally तुमने सही से handle कर लिया. So in blue green this will work.
Slight possibility of failure, right? If a new deployment and new port that is deployed, traffic is still not routed. We delete the column, but older port reading from there. Okay, no,
But nobody is reading big int. No,
reading.
everybody is reading int only.
Yeah, it's in step 3.
Right? तो ब्लू ग्रीन में ये एक्सीडेंटली हैंडल हो जाता है बिकॉज ब्लू ग्रीन इज लाइक इट्स बॉर्डर लाइन टेकिंग अ डाउन टाइम इफेक्टिवली, क्योंकि वो एक शॉट में स्विच करना इज हार्ड, राइट. बट इफ यू मैनेज टू स्विच इट लाइक सिंगल रीजन अगर आप हो एटसेट्रा एटसेट्रा, or not even that, like even in multi-region it's okay, like across regions these migrations can happen separately. तो ब्लू ग्रीन में रोलिंग में क्या होगा?
Uh, uh, like might be the silly question, but right now we have a new deployment, right? Uh, and then we deployed the older one. At that point of time, we remove the ORM code changes plus delete the column. But delete column changes happens, I mean, in the starting, like when code is creating or starting boot up time. Right? At that point of time, new code write the into begin, right, in the database, and we don't have a new column.
Yeah, exactly. Yeah. So while in the deployment, this might not be an issue. In the rollback, this becomes an issue. Because you would have deleted, like in the rollback, you basically have, so rollback mein, you have new stack running, then you have new, and now the old one comes up, which is going to do the down migration. But can it do the down migration? So think of this as reverting the PR. राइट, माइग्रेशन मैंने डाला ही इस पीआर में था, अब पीआर ही अगर हट गया तो ओल्ड वाले को तो पता ही नहीं है कि डाउन माइग्रेशन करना कैसे है. द कॉलम इज एक्चुअली गोइंग टू रिमेन देयर, only the copy in ORM will go away. There is no migration, no down migration that can happen here because old वाले को पता ही नहीं है. Rolling में the same problem will happen, right? If people want me, then like I'll double click, but yeah, the same explanation pretty much applies to rolling. But the rollback, it's an issue. So the right way to do this is to actually do key, you just add the column first. And then the second deployment is going to have the ORM having the copy of int to begin. Even if you roll this back, the column still is there. तो rollback में कोई पेन नहीं आएगा. So that is a better way of executing this step 2. जितना आप granular कर पाओ, right? Step 3 पे आते हैं. तो step 2 का we are saying कि अगर इन दोनों को अलग अलग किया then we can roll back peacefully, right? So 2 का roll back is possible. What happens when 2 plus 3 we want to roll back? So now the column is there, big int is being written also, big int is being referred also. तो अभी 2 plus 3 मतलब add column, ORM copy and read big int. अगर ऐसे डिप्लॉय किया है तो रोल बैक उल्टे डायरेक्शन में होगा. तो व्हाट हैपेंस व्हेन यू रोल दिस गाय बैक? यू स्टॉप रीडिंग. ठीक है, एनीवेज दोनों जगह राइट तो हो ही रहा था, तो द प्रीवियस कोड विल जस्ट वर्क फाइन वेयर विल स्टार्ट रीडिंग फ्रॉम द इंट इंस्टेड. So that's fine. And then this rollback we have figured out. So you stop copying and then you delete the column. So this is safe to roll back. How do you roll back with 2 plus 3 plus 4? This stop writing int, right? Can you really roll it back? safely. Can you roll this back? If you deployed this, some rows are not going to have int at all now. तो यहां से अगर आप रोल बैक करते हो, you can't go back. Because those rows are not going to have an int.
But still, we can go to step 3, right? Because we are not writing in the old int, but we are writing in the big int anyways. So third step is about writing from big int, right? Yeah.
Exactly. So if you wanted to go from step 4 directly to step 2, you can't do that. And that's the beauty of the solution. So step 4 से 3 पे आप actually जा सकते हो. Doesn't matter कि int आपने नहीं लिखा है. Because step 3 में तो big int ही read हो रहा था. Step 3 में big int ही read हो रहा था. Right? तो 4 से 3 आप जा सकते हो. वो integers का जो gaps है, you can fill it with a migration.
Yes.
int जहां पे missing है वहां डाल देंगे फिर से. And then we will go to step 2.
Right.
तो यहाँ पे रोल बैक में backfill int का एक एक्स्ट्रा स्टेप आ जाएगा.
Right. Yeah.
या जैसे हम हिस्ट्री वाले इंट को बिग इंट बना दिया था.
Step 2.5, I think.
या मतलब at
Copying
one
the old
point,
data to the new data, right?
yeah, at one point we
हाँ.
started making new records as a big int, and then we
Yeah.
historical data copy from int to big
Yeah.
int. The same migration we'll have to do.
Yeah. So now that you guys understand this, right? Can we rewrite the table? Can we rewrite the table in a better manner? Right? अगर ये write और read है, let's do the deployments and the rollbacks. कि कौन से sequence में करेंगे. And remember, this is the template. Okay. So we are taking a database example to understand the template, but the template stands for itself. Same चीज आप और situations में भी apply कर सकते हो. So with that, first, so you have write to old and old. Then you do a migration to add column. तो अगर मैं deployment green में लिखता हूं और roll back अगर मैं red में लिखता हूं, then थोड़ा सा space I need to use better. और ये होगा roll back. पहले अगर आपका old और old था, then you add column. So rollback is going to be delete column. Next, you write old plus new. So rollback is going to be just write old. That's fine. Then you do backfill of data. जो पुराना वाला था, इसका rollback कुछ नहीं है. You can actually clear out the backfill, but you don't need to because nobody is referring to it. So the rollback is trivial. यहाँ पे कुछ नहीं करना है. Rollback में NA लिख देता हूँ मैं. Once you have backfilled the data, this is logically your step 2 and 2.5. So 2.1, 2.2, 2.5. 3 में करेंगे read from big int. So इसका रोल बैक है read from int. और रीड फ्रॉम बिगिन अगर कर लिया देन यू राइट ओनली न्यू एंड दिस इज स्टेप 4. राइट न्यू ओनली, बट इसके रोल बैक के लिए यू विल राइट ओल्ड, बट बिफोर यू राइट ओल्ड आपको करना पड़ेगा बैकफिल. अगर ये रोल बैक करा तो पहले बैकफिल करो गैप को एंड देन स्टार्ट राइटिंग ओल्ड. ओल्ड प्लस न्यू. दिस इज द क्रूशियल स्टेप. And then you actually delete the column. Here is where you are like really throwing away the data and you're really committing to this. Delete all, right? So this is roughly the zero downtime deployment deployment and rollback ka nuances, where you might have to backfill at strategic places. As long as you're street smart, I think you'll figure this out at runtime as well. इसको कोई रट्टा मारने की जरूरत नहीं. So this is the more complex version, like ZDR in detail with rollbacks. And simple वाला अगर चाहिए तो this is the simple one. Any questions before I move on to more examples, and we'll move faster from here because now you've seen one example. No questions, folks. Either I'm explaining this too well, or you guys knew this already, or like this is not making any sense.
No, you are explaining too well.
I highly doubt it. एक तो question होगा. Smith? Any thoughts?
No questions. Oh, at least.
पूरा समझ गया.
वो तो थोड़ा ओवर स्टेटमेंट होगा लेकिन फिर भी
I think when you use it is when that reality check why is going to happen. कि कितना समझा है कितना नहीं. But fine. I'll take you on face value. तो वो examples हमने लिखे थे कहाँ? हाँ ये रहा. So we looked at change the data type of column का ZDR. Delete column का कैसे होगा? Look at this template on the bottom right. Delete column का बताओ कैसे करेंगे? Anybody wants to take a verbal stab at it?
First remove the usage और फिर
ये रहा.
I think the first part would be to stop writing.
Reading, right? Stop reading.
Yeah, stop reading.
reading first stop करेंगे फिर then write.
Yeah.
So go through the template, right? You are trying to solve it like without the template, and you have just one decision to make. कोई step करना है कि नहीं करना है. That's it. Maybe this is a more trivial example. So some of the steps you might skip, but strictly go through the template and let's work it out. Delete में क्या होगा? तो write और read कॉलम बस डिलीट करना है. तो अभी write हो रहा है old में, read भी हो रहा है old से. तो the first change is कि दोनों जगह write करेंगे old plus new में. New तो कुछ है नहीं, right? Step 2 becomes a no op. ओल्ड प्लस न्यू तो कुछ है ही नहीं, राइट? तो न्यू तो है ही नहीं यहाँ पे. तो स्टेप 2 कुछ नहीं हुआ, बट स्टेप 2 कमिटेड मुफ्त में. स्टेप 3 इज कि दोनों जगह राइट करो. तो राइट में तो कुछ चेंज था नहीं, सो दैट विल रिमेन द सेम. ये बोल रहा है न्यू से रीड करो. इसका मतलब क्या हुआ? न्यू तो है ही नहीं, मतलब तो क्या करना है यहाँ पे?
Removing the reads.
एग्जैक्टली.
Bright as well, right? I mean, if
No, so
there is
step
any
3
bright.
is then you've like shot yourself in the foot. अगर तुम राइट और रीड दोनों हटाते हो एक शॉट में, इट्स
Okay.
नॉट बैकवर्ड कंपैटिबल.
रोल बैक्स में दिक्कत होगी ना.
रोल बैक में दिक्कत. तो स्टेप 3 भी हो गया कि न्यू है, मतलब लाइक कुछ नहीं, तो रिमूव रीड्स. एंड दिस इज रिवर्टेबल. यू कैन सेफली रोल इट बैक. और जब स्टेप 4 पे जाओगे तब यू विल ओनली राइट न्यू. तो न्यू तो कुछ था ही नहीं, but old you need to like delete. So now is when you'll delete the writes. Reads तो चले ही गए, and then you will delete the column. Right? यहां से अगर रिवर्ट करना है, मतलब डिलीट कॉलम में आपने एक्चुअली कमिट कर दिया, एंड यहां से रिवर्ट करने की जरूरत पड़नी नहीं चाहिए. बट यहां से कर सकते हैं रिवर्ट अगर करना हो तो. what are the backfill steps that we will have to do?
मतलब फिर तो कोई डिफॉल्ट वैल्यू डाल के ही फिर ऐड करना पड़ेगा, क्योंकि राइट्स तो एनीवे लॉस तो हो ही गए हैं.
Right.
Maybe the trivial solution, change the column name and leave it for 1 or 2 days. If any failure, then we can again change the column. So data we might not lose. That's
Yeah, so then rather than changing the column, anyways कोई read तो कर नहीं रहा है, you leave the column as is without
Okay.
changing the name, right?
Mhm.
So delete is not really revertible, right? To simplify, once you've deleted, you've committed. एक गया, मुझे नहीं चाहिए, so you've committed to it. So delete is very destructive, and you will see various software teams having a policy कि delete कुछ नहीं करना है. Delete like 6 महीने बाद करेंगे, 1 साल बाद करेंगे, at which point you really know कि कुछ आने नहीं वाला है from anybody. So deletes are like, people are very, very pessimistic when it comes to doing these destructive things. This is very destructive because you can't roll it back. Step 4 से अगर roll back करना हो तो कैसे करेंगे? So you've stopped writing, right? Step 4 में you've stopped writing, but now you want to roll it back again because you've stopped writing. कुछ नहीं कर सकते. There, वैभव का example actually comes handy. जहां पे you write to a new column, like a different column, a dummy column. ताकि जरूरत पड़े तो वो डमी कॉलम से आप फिर से वापस लेके आ सको. राइट? सो यू विल सून रियलाइज कि यार
4 से
ये
3
भी
तो हम जा ही सकते हैं ना डायरेक्टली.
4 से 3 जा सकते हो, बट यू विल हैव डेटा होल्स. व्हाटएवर एंट्रीज वर रिटन व्हेन यू वर एट 4, यू आर नॉट राइटिंग एनीथिंग. तो उन रोज में तो मिसिंग होगा वो.
But in starting, we
बट
assumption is that
एनीवे
right,
वो
write
रीड
and read.
रीड
Right.
तो नहीं कर रहा है ना वो डेटा को, एनीवे वो एम्प्टी होगा तो।
Sorry, one person at a time. I understood none of you. Sid, you go first.
मतलब अगर 4 से 3 ज्यादा है तो एनीवे हम रीड तो कर ही नहीं रहे, सो वो एम्प्टी भी होगा कुछ रोज, सो वो तो चलेगा क्योंकि रीड तो एनीवे नहीं कर रहे।
हाँ, right. So 4 से 3 अगर जा रहे हो, then you will probably not, like you'll want to you would want to go all the way back. आप 4 से 3 पे अटकोगे नहीं, आप 3 से 2 पे भी जाओगे। तो 3 से 2 पे जाने में दिक्कत हो जाएगी, because now there is some data holes, और ये 2 का read is going to be troubled. So in that sense, step 4 is also not revertible.
But in starting, we assumed it, right? There is no writes in this column. Otherwise, we have to remove writes as well in step 2. So, I mean, we can deal separately these two things, write a column and then delete the column.
Yeah. So to delete a column, rather than, so the problem here is that you don't have this new. That's the issue. And the right way to do the delete column, right? Delete column in a ZDR way is to actually have a dummy column. So you actually put in a new column. Don't strike this off. That's the solution. You have a dummy new where the reads will get removed. Like this will remain the same. You're not going to read from the dummy new, but you at least have the dummy new. So यहाँ पे भी dummy new है. And then you have stopped writing. You have stopped writing to the old basically. So यहाँ पे old और dummy new दोनों में write कर रहे हो. Step 4 में dummy new में write होगा. यहाँ पे dummy new में write हो रहा है अभी भी. And then you are deleting the column. Because you are writing it somewhere, now this is reversible.
So, isn't it kind of a change column name problem? And if we
Yeah.
and
Yeah,
at
this
the end, if it
effectively
is and at the end, if everything is okay, then we can delete the new column.
correct. Yeah, correct. Except that you are not just changing names, you're actually creating a new column and writing the value there. So yeah, it's equivalent, right? So इसका simpler version, delete column का then simpler version is कि if you were writing in the old and you were reading from old, then you keep writing to old, but you stop reading. And that's it. So टू में कुछ नहीं होगा. 3 में you keep writing to old, but you stop reading. And then 4 में भी आप कुछ नहीं करोगे. This is the simplified version. Effectively वो dummy column अगर आप करते तो वही हो जाता, because all you want for rollback is कि कहीं ना कहीं हम लिखते रहें. You keep writing to the old one then, right? को हटा क्यों रहे हो, फिर नया column क्यों डाल. And then fifth one is like when you're really committing. जब आप ये column उड़ाओगे, which is delete column, which is again a very destructive op. This is when you're really committing. and there is no going back. There is no going back. So it's just one step ZDR basically. 2 or 4 नहीं होगा. So that's delete column. ठीक है?
I mean, one question, I mean, not related to that delete thing, but is there any way to check, I mean, in kind of database, is this column is used by any API application or not, using some strategy or monitoring method?
Yeah. You can do all that. You can do all that. You can scan the code. You can ask around, right? You can do all sorts of technical confirmations कि अपने को rollback नहीं करना पड़ेगा. But
I mean, without asking any team, is it possible directly from the database? Okay, in last month there is a 0 read on this column or something like that.
yeah, good question. That will be an extremely healthy way to decide this data-driven in a data-driven manner. So some databases give you that stats, some don't. Remember the rule of thumb कि there is no free lunch, right? तो अगर तुम database stats मांग रहे हो कि ये कॉलम कितनी बार रीड हुआ, you have to pay a penalty, performance penalty. But yeah, so even if databases have that facility, you will have to switch on that instrumentation और उसका आपको वो देना पड़ेगा, overhead pay करना पड़ेगा.
Got it. Okay.
Yeah.
But one question, if I think your question is on the context of this rollback, right? So your application would be the only one, right, reading from the database. And if you have removed the read, right, so no one will actually be reading from the database if your database is specific to your service.
I mean,
not from the database, but from an application, from an external world's perspective, if you consider application as one coherent unit, then the question gets transformed into, does the rest of the world need this column or not?
no, Himanshu, I mean, stated correctly. If, I mean, the data generally in microservices, one service is on the database, right? But it is not always the case. Like some of the, I mean, unknown service will also connect the database and read from the database. Might possible, right?
So it's then though everything is possible. Then though you can go to the database storage engine and then mess things up over there also, right? But it's not expected. That's not how people build systems. So you can assume कि भाई एक DB को उसी का service access कर रहा होगा. So yeah, like that you can assume. And what I'm trying to say is then कि DB level पे कोई read कर रहा है कि नहीं is not the interesting question. Because DB level पे तो only your microservice is reading, as Himanshu said. So DB level reads are not interesting. Application level पे if the rest of the world needs it or not is the interesting question.
In my current talk, other services is also reading, writing in the DB. So
Yeah. Well, these are actually interesting combinations, right? There are some benefits to doing that. So it's an unconventional architecture. It's definitely an unconventional architecture, but there are benefits. By reading from the same DB, there are things, yeah. And you'll have to take care of a few things. For example, whenever things change in the DB, now rather than changing one microservice, so this application layer changes that we were talking about, this ORM that we were talking about, you have to handle in both. And in that sense, you consider both of the applications logically as the same application, even though one might have one Docker file, the other might have other Docker file, completely different repos, but logically they are the same application. And you need to apply the ZDR playbook as if they were the same application. तो अगर कुछ एक जगह कर रहे हो दूसरी जगह भी करना पड़ेगा और वो साथ में रोल आउट करना पड़ेगा. And that साथ में might become more and more difficult because now they might be two completely different deployments behind two different ALBs. So yeah, all of that you will have to like dereference and handle.
And if we don't know how many services are using, so is there any data driven method to identify this?
If you don't know how many services are using,
Specific table, let's say. So
yeah, the data driven method would be to one do a code analysis saying कि इस टेबल के नाम पे कौन कौन क्वेरी कर रहा है, so you discover कि in how many code bases does this table name exist. To even narrow down the code bases, you might first check if you might start with the database and say कि from which all IP addresses am I getting the incoming connection, because you can't read from the DB without connecting with it. So you start with the connections, identify the IPs, map the IPs back to the services. So now you know that these three services are connecting to the DB, and then you dig into those three services ka code to see who is firing queries on this table. Right? Because DB will not give you anything beyond that. DB bolega this is the client. Yeah, but if the code analysis is unsuccessful, then yeah, it goes into the expert territory, where you'll have to do some investigative work, right? वो जासूसी करनी पड़ेगी, CID करना पड़ेगा फिर वहां पे थोड़ा सा. So you'll have to change things to see what breaks, and yeah, I'm not even sure if I can describe that very, very succinctly. But yeah, you'll have to be smart.
An individual step, like we have to try and kind of.
हाँ, वो trial and error हो जाएगा फिर. Yeah. ठीक है. So delete column देख लिया हमने, which is just like step 1 and step 3. सीधा 2 और 4 eliminate हो गया delete column में. ये making column not null, उसका क्या सीन है फिर?